Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions. Co-hosting with me today is David Charbonneau.
I'm David Charbonneau, and I'm excited to be the co-host for this episode of Open Source Directions. I lead the development of open teams here at Quansight, and I'm based in Durham, North Carolina.
Jim is our first guest today. So Jim, you want to go ahead and introduce yourself as well?
Hi, I'm Jim Christ. I'm a software engineer at Anaconda, primarily working on Dask. I'm located in Austin, Texas.
Thanks, Jim. And for our second guest today as well, we have Tom. Tom, you want to introduce yourself?
Hi there, I'm Tom Augsburger. I also work for Anaconda on open source things like Pandas and Dask.
Excellent. Thanks so much to both of you for joining us today. And as usual, before we go ahead and get into our discussion of Dask, we're going to do a brief personalization section. So this week we have our famous Tweet of the Week section where each of our panelists presents a tweet that they've recently been enjoying. Jim, you're up first, it looks like.
Yeah, so I have this tweet by Jeremy Howard. He published an article earlier this week on evaluating Swift as a good high-level language for numeric programming, and it turns out to be a great language. I look forward to learning more about that.
Very cool. Thanks. Tom?
I've got a more general recommendation of a person to follow, Todd Naziri. He's a visual effects artist at Industrial Light and Magic. They do like a whole bunch of the VFX work in films, so like all the Star Wars stuff. Anyway, he does like a lot of tweets about filmmaking and visual effects. He's really interesting to follow.
Very cool. Yeah, thanks. David, you've got a tweet on deck here?
Yeah, I really like it when people make animated illustrations of mathematical or science concepts. And Jordan Ellenberg tweeted an illustration someone had done of the fast Fourier transform. And it's got this really, if you go and look, one of the first things it shows is a fast Fourier transform that when unrolled, it draws like a hand drawing on a piece of paper. Very, very cool illustration.
Neat. Yeah, a couple Viz ones this week. For my tweet, our very own Aaron Muir said this week, the omnipresent pull request header on GitHub would be useful if it included the branch name. The one thing that I find myself scrolling to the top of the page to find out all the time. I couldn't agree more, Aaron. Yeah. Thanks for that tweet. So at this point, we're going to go ahead and dive into a brief introduction of Dask and talk about Dask before we move on to a demo and our wishlist discussion later on. Dask is a flexible tool for parallelizing various parts of the Python ecosystem or Python code if you're not familiar with it. It has about 4,000 stars on GitHub currently and approximately 1 million downloads from PyPI or the Cheese Shop and about 250K per month from Conda. So that's sort of where it sits. It's a very popular project. It's been around for a while and we'll get into all that right now. So David, you want to take our first standard question here?
Sure. Jim, Tom, why was this project started and what need does it fill?
Yeah, so Dask was started around the end of 2014, beginning of 2015. It spun out of the Blaze effort, which was led at then Continuum, which is now Anaconda. So Blaze was an effort to scale up Python computing. Dask was originally designed to be one of its backends, but was found to be very useful on its own, and development kind of shifted to focus just on Dask as a tool on its own. At that time, most libraries in the scientific Python ecosystem were single-threaded, meaning they only take one core, and were limited to in-memory data sets. You couldn't do large computation. The goal of Dask was to take that existing ecosystem and scale it up to larger problems by using all of the cores on a laptop or workstations or many machines in a cluster without having to rewrite the ecosystem to leverage the existing Numpy, existing Scikit-Learn without having to do a ton of work, but just make it scale up. Scale data analysis with a familiar interface, so not having to learn a new paradigm. If you ever had a problem with Numpy or Pandas where it's working great on a small sample and then failed to scale up, Dask might be helpful.
So are there any alternative projects out there to Dask? What's the competition look like?
Yeah, there's quite a bit. First of all, if you're sticking, just in the standard library,
Hmm.
and want to do, some sort of reasonably scalable parallel data processing type stuff, you can get decently far with like concurrent.futures to do some simple larger than memory data analysis on like lists and sets and things like that without too much effort. Going beyond that, third-party packages, there are a whole bunch of ones. Some older ones are like Luigi or IPython Parallel. There's some overlap there, although they're quite different. And then the biggest, competitor or whatever is probably Apache Spark. It provides like a big, distributed data frame in their RDDs for doing large distributed data processing. So that's probably the biggest and most comparable competitor, if you want to frame it as that. And then there are a whole bunch of newer ones coming up as well. So there's the Ray project, which I think was initially focused on like deep learning applications, but is also kind of expanding into the data frame type workload with Modin, which spun out of Ray. And then there's a new one that we just saw called Mars, which comes from, I think, Alibaba. And it's very new. It was just announced like last week. So this is an active area of development.
Yeah.
So what technology is Dask built on?
That's a complicated answer. Dask is kind of spun out from being a single tiny project into being kind of an ecosystem. So the core of Dask is a task graph and a scheduler infrastructure, and that's all pure Python. Runs just as well on PyPy as it does on CPython. And then based on that infrastructure, we have built up a bunch of collections, so things for solving various domains. So there's things like Dask Array for scaling up Numpy, Dask Data Frame for scaling up Pandas. These all wrap the existing SciPy ecosystem projects there, and a lot of those are C extensions. So Numpy is a big pile of wrappers around C extensions. SciPy is a bunch of old Fortran libraries wrapped up. Dask is able to leverage these and scale out. And then the distributed scheduler is built using an asynchronous library called Tornado, which is also the core of Jupyter.
Very cool. So who started Dask? Who started the Dask project originally?
Yeah, so Matt Rocklin was the original author. I think it was like over a Christmas break or something. He went home from work and started toying around with this, brought it back. Jim, you were involved pretty shortly after there. There were probably a few other people in the first few months.
Yeah.
Is that right? Yeah, and then it's slowly grown out from there, picking up contributors along the way.
Who maintains the project now?
So there's a lot of maintainers. As I said, Dask has kind of become an ecosystem. So frequently we have people that maintain a single project in it. We have a bunch of different deployments. You can deploy on HPC clusters, deploy on Yarn, deploy on Kubernetes. Oftentimes one person or a small group of people will maintain the deployment strategy that works for them. There's Dask sub-projects for different domains. There's a whole one for images that is mostly run by John Kirkham, Genelia. There's the Dask core, there's the distributed scheduler. So it's really specific to who is, or what the project is, the subcomponent. The day-to-day maintenance lately has been mostly run by Matt, with Tom, myself, and Martin also taking some of that. This is fluctuated over time depending on how busy people are. It's an open source project.
Right, so there's a natural flow to how all of these things happen, of course. So what communities are the users and contributors from? Where do you get most of the people who use Dask and help maintain and contribute back to the code bases, really?
Yeah. It is an open source project, so it's impossible to say for sure. There's a big blind spot there to who's using it. But some groups are quite happy to talk about how they're using Dask. So academics especially are very public about their work. They have to be. So the Pangeo group, which we'll see a bit of later, a bit of their work. They're a bunch of climate scientists, earth science people that were interested in doing large distributed scalable data analysis, either on HPC machines or on cloud, on clusters in the cloud. Anaconda also, we work with like finance companies who are wanting to use Dask. They don't want to maintain their own internal distributed scheduler because it's difficult.
Mm-hmm.
So they're happy to push that maintenance burden upstream to open source, but they don't talk about what they're doing as much. We work with government people as well, so their users, national labs, and then your wide variety of use cases. We get a lot of questions on Stack Overflow, just from random people. Dask Data Frame is quite popular there. So yeah, it's hard to say for sure, but it's a good
the traditional smorgasbord of scientific computing in some sense. Yeah.
Yeah.
Is the project participating in any diversity and inclusion efforts?
Nothing super formal right now. We
Yeah.
are currently going through our governance. So there's a Dask governance repo. If anyone wants to chime in, we're mostly trying to model it after other people's work, taking inspiration from Jupyter and Scikit-Learn and stuff. We're trying to get new contributors. So when a contributor comes along, new, especially from an underrepresented group, we'll try to be very prompt and encouraging, trying to help them stick around and be successful contributors to open source projects. But like many projects, people get busy and come and go as they have time.
Excellent. Well, yeah, I look forward to that governance discussion and hearing how that goes. At this point, we're going to get to the fun part where we get to see Dask in action. So I believe you guys have a couple of demos ready and available for us, and you want to share your screen and walk us through those. Yeah, let's get rid of that. Oh, there we go. Should have removed that title screen a long time ago. Always seems to happen.
I believe this should be working. How do I make it big? Oh,
there we go.
So we have this Dask examples. So examples.dask.org is a live set of runnable examples. So you are all free to follow along if you want. I'm just going to walk through a couple of these. Dask has been around for coming up on 4 years, or a little over 4 years now. So we have a lot of resources on the web. There's many past talks. We have examples in a repo here. We have a larger set of tutorials elsewhere. So we're just going to be running through a couple of very quick things to give an impression. But there's more things to follow along at home if you wanted to later. Anyway, I'm going to walk through the data frames example here. So examples.dask.org/data frames. This is a rendered version of the notebook, but if I click this little launch binder button here, this is going to spin up a binder notebook. So if you're not familiar with binder, binder is a resource for running notebooks, Jupyter notebooks in the cloud. So it's going to drop me into an environment here, and this will be a runnable example. It's going to take a second. Let me get the other one going too while we wait. Maybe you should have started this up earlier. While I am waiting, pull up a couple other resources people are free to use at home. So all of our Dask stuff is in the Dask GitHub org. So we have a tutorial. This has been given at several data conferences, Dask-tutorial. It's designed to be read from home, so it's got a lot of pros in it. You should. And then.
Very cool. So are these examples here mostly put together by you guys and the Dask kind of core team, or are they?
Yeah. If you have examples that you think would be good, the Dask examples section, we're trying to have simple, concise ones for people to see stuff. We have another repo called Dask Stories.
Oh, that's fun.
And so this is for people that have used Dask. You have a large example.
I see.
So like
Ice Cube. Yeah.
So how have they used it, how it helps them, pain points of using Dask. If you have used this is very helpful for us as maintainers and for the community as well to see how the tool can be used.
Yeah, that's awesome.
In a row, and it's if you just file a PR or an issue.
I think more projects need something like that.
Yeah. That's really good from the marketing side, I feel like, actually.
It's also useful to know what's useful for people, where we should focus our efforts.
Sure.
All right, so this has dropped us into a Jupyter Lab setup here, which is nice. Notebooks are on the left. If you're not familiar with Jupyter, this is a running notebook here, and then we have a couple of things to our dashboard, which you'll see in a second. So I'm going to run this first cell. It's going to create a local cluster. So Dask has many different scheduler backends. We have a threading one that will run completely in process. We have ones for multi-processing. And then the main one that's fanciest and has the most features is the distributed scheduler. So from dask.distributed, I'm importing something. And then that's kind of a misnomer because the distributed scheduler runs perfectly fine locally. So here I have created 2 worker processes, each with 2 threads, and allowing each of them to have 1 gig of memory. Over here we have a task stream plot and a progress plot, and those will make more sense later. So here I'm going to be using Dask data frame, which is one of our collections. Dask collections are meant to look like their in-memory counterparts. So Dask data frame should look a lot like a Pandas data frame. It just happens to be out of core and parallel. So I'm going to make some fake data. Unlike Pandas, these data frames are lazy, and so there's no actual data here. We know what it looks like. We know it has an ID column, a name column, an X or Y column, but we don't actually have the data yet. That won't happen until we call compute. We also know its D types. So you know, like ID is an int, name is an object, which means it's a string, and then X and Y are both floats. Set some precision settings here. If I call head, which is the Pandas method for getting the first 3 rows, we actually do sim compute. So over on the right here, we can see, so I'm going to minimize this, get more screen space. Over on the right, we see our task stream. So this is a plot of showing progress here. We have a computation here called make time series head, and then we have another computation here called head. So there's a graph underlying this, and the scheduler walks through that graph and done computations, and over on the right, we see them processing. So here we've computed just the first 3 rows of this time series, and you can see the actual data. We can write larger, more complicated Pandas expressions. So here we filter on Y, group by name, take the standard deviation of X, just some random Pandas operations. Looks a lot like Pandas code. Note, we still haven't done any computation yet. We've just built up a graph behind the scenes, and then we can actually call compute. And over on the right, we're going to see computations happening again. This is a little more interesting now that we're actually getting a couple things happening. So
very cool.
In the task stream, it's a worker thread. So we have 2 worker processes, each with 2 threads. So we have 4 rows. And in each block is a task. And then the x-axis, see how the task is processed over time. The red indicates data transfer. So the scheduler is smart enough to try not to move intermediate results. It'll say, oh, this computation, this little bit of the graph needs these intermediate results. I can move the computation to where the data currently is rather than moving the data. And that tries to minimize data serialization, which can be expensive. But sometimes you have to move things around. And so red is data transfer. That's the cost of sending some block of a memory from one computer to so we actually did a computation. Computed results are a Pandas data frame. So calling .compute on a Dask collection takes the distributed version and then converts it to an in-memory version. So a Dask data frame converts to a Pandas data frame, a Dask array converts to a Pandas or a Numpy array. I'm going to pause on this. There's other operations here you can do. We have integration with Scikit-Learn. Things work fine. There's also a Dask ML project, which has got different things you can do. I'm going to pause this and just go to a different notebook just to keep things moving. So for things that don't fit into the collections model, things that don't look like Pandas data frames or Dask arrays or Numpy arrays, we have a general thing called Dask delayed. And this is a tool for parallelizing general computations. So I'm starting up another cluster here. So again, the task stream plot and the progress plot. Create some simple functions. We're calling sleep in here just to add some time to them so they don't run immediately. We have inc, which increments a number, dec, which decrements a number, and add, which adds 2 numbers together. If we run them like normal Python functions, this is going to take around 3 seconds, or 1.5 seconds on average, random sleep time. because each will take some time, they have to be done serially. Inc is called first, then dec, and then add. But if we wrap them with Dask delayed, we can parallelize them with Dask trivially. So now we call the same things. This code looks the same as this code, but nothing happens. And the reason nothing happens is because Z is not a result yet. It's a delayed value. It's got a graph behind the scenes. So we can visualize that graph and see the graph that Dask built up. So Dask is able to know that it can run inc independently of dec and then combine those results together with add in the middle here. And it can run dec and inc at the same time and run them in parallel. And so this should run a lot faster than it did in serial. So here's the inc result, here's the dec result. See, they're happening at the same time, and then it runs add together. So this can be used to parallelize existing code bases. Oftentimes you might have things that look like Numpy or Pandas, but a lot of your code is loopy Python functions doing some data processing. We found that if you find where your hot loops are, you can sprinkle in calls to Dask delayed and add a couple compute calls and parallelize existing code bases pretty easily. So here,
it's really neat.
Yeah. This has been are super useful, but really we find a lot of projects. This is what's really nice. So this has been used to parallelize Scikit-Learn bases.
Right.
So we have Dask.ml, which is a project to parallelize existing Scikit-Learn type algorithms, and this is used internally to do like parallelized grid search. Projects Teapot, I believe Tom contributed to parallelize their code base as well, just sprinkling some calls to delayed. This has been used a lot in client projects, so we've done some consulting work. This has been by far the most useful thing, at least in those code bases. So over here we can see things keeping going here.
Yeah.
I'll leave the examples of that. Examples.dask.org, we have a whole bunch of runnable examples if people want to try things out. Should be a decent overview of the functionality of the project. And then Tom, I think, wanted to show something.
Yeah. So I'm going to show the Pangeo. So Pangeo, I mentioned earlier, it's that group of climate scientists who were wanting to do the scalable data analysis. They also have a binder. So this is like binder.pangeo.io. And they've got an example up here. They have a whole bunch of example notebooks of real science stuff. Only this one's binder, the version Jim was showing, is a tiny little instance. You get like it's like public free service, and there's hosting that for you to play around with. This one's backed by a much larger cluster. So we're going to ask for a larger machines. We're going to get a cluster with 20 workers in this case, instead of Jim had, I think, just one worker with 2 cores. And so this example, I don't know exactly what it is. It's something about surface sea altimetry, I guess like sea levels rising over time. So it's using Xarray, and Xarray is not developed by Dask, but several of the Xarray developers are also Dask contributors, and Xarray uses Dask array internally. And if you're not familiar with Xarray, it's like a labeled NumPy array, roughly. It's more than that, but an Xarray data sets is made up of NumPy arrays, or Dask arrays in this case. Okay, so we've connected to this cluster and going to do some visualization. So selecting all of the points for this day, I guess, and then plotting them. So you can see over here we have the task stream. Since we're just selecting for a single day, and we have ZAR, it's a good file format for this type of stuff. We don't have to scan the entire data set to select out this day. We only have to get the data for a single point, so we can quickly access single regions. I don't know exactly what this is showing, but there's like the Pacific Ocean here in the middle, the Atlantic Ocean over here, and the color represents something. I'm not sure exactly what, SLA, whatever that is. And so now we're going to do a large computation. So this is a 74 roughly gigabyte data set. And it's kind of a simple computation, but it's a big one. We're taking the mean over these 2 dimensions. So taking the mean over latitude and longitude to get the, global mean sea level over the time period. can see we have one taskbar here per core, which is I think 40, and so you can see that means a relatively easy thing to parallelize. So we're keeping the cluster nicely saturated, and we're going through and doing a whole bunch of reading in of data. That's the ZAR key here, taking the mean of that chunk, and then aggregating that between the various chunks to get the final mean. And this will finish here in just a second, and we can plot it. And you can see that over time, the sea level has risen, and you get the seasonal variations and then some sort of average. So that's an example. One thing to notice here, like this is just the average over. This is just regular X-array code. But since we loaded the data set from the ZAR, this distributed ZAR data set, it's able to use Dask internally. So we've connected to the cluster, and beyond that, you're just doing your normal scientific workflow.
Yeah, that's awesome. That's a really cool example of visualization. David, do you have any comments or questions, or do you guys have anything else you want to add on the demo section?
One question that I had was the data already distributed, or did it get distributed when you were doling out the work tasks? Like, is the code running where the data is, or is the data moving to where the code's going to run?
Yeah, sorry. So in my example, the data was stored in ZAR format on AWS,
Okay,
or in this case, it was Google Cloud Storage.
So they're pulling it out.
So it was all remote.
Yeah.
Mm-hmm. And then so that's kind of been a big important thing. Like the NASA and many government agencies are starting to upload their public data sets to the cloud, which is really increasing the need for moving compute to data, because it's just not possible to download these large data sets locally every time you want to do an analysis.
Well, yeah. One of the issues here too is a lot of the legacy formats, like HDF5, which is, I guess, not legacy, it's still heavily used, but older, don't scale well to the cloud. They weren't designed for that kind of environment. And so new things like ZAR or things that will work well, we're able to pull down just a small section of the array to work with. Work pretty well with Dask.
Awesome.
Yeah, I think HDF5 has some initiatives to be kind of more cloud-based, but yeah, that's...
So there's an abstraction for the backend. Well, actually, you would know. I don't know to tell you this. I will say this to the audience. There's an abstraction for the backend, and so you can have, there's some experiments on running like HDF5 where the data is stored on S3.
Right, yeah, I think the real difference between things like, we're way off in the weeds here now, but between Dask and HDF5 and things is like HDF5 is for really traditional HPC kind of infrastructure, whereas ZAR and some of these other compressed distributed typed data formats are for, they have a more cloud-oriented API, right? They've got REST APIs associated with them in a lot of cases. Yeah. Very cool. Yeah, it's interesting. I haven't seen ZAR used on such like a large project. So that's nice that Pangea's using it. Even I learned something. Okay. Well, that's pretty neat. So at this point, we're going to transition to the wishlist discussion. So Dask, there's a lot of people who are using it. There's lots of people who want to use it and perhaps want different features and different parts of the Dask ecosystem. And so we're going to spend, the next chunk of time here discussing what those things are. And I'm sure both you, Jim and Tom, have wish list items of your own. So this will be relatively informal compared to some of our other discussions on previous episodes, but I think the first item up for discussion is the governance document or the governance discussion. So either one of you want to take that and sort of dive into a little more detail there?
Sure. So we have, we're pretty early in the talks here, but we have a governance repository where we're walking through the governance steps we want to take. The goal here is to create a governance model as our team becomes more distributed. We were always an open source project, but we're getting picked up by more and more organizations, and there is some desire here to have some kind of formal thing just in case we need it. Hopefully, I think the goal here is like governance should never come into effect. We should never have these kind of disagreements with these kind of issues. But if we do, we want to have a formal process for them. We're also trying to become a NumFocus affiliated project, and so a lot of these are requirements to go along that way. But yeah, we're still well within discussions. Nothing is really set in stone at this point.
So is there a way for people to solicit their ideas or thoughts
It's all in the open. So there's issues people are discussing. If you want to chime in, if you have thoughts, if you have experience, a lot of us don't have experience writing these documents.
Right. Yeah. So, go ahead, Tom. Sorry.
No, I was just going to say there's like interesting problems, challenges, whatever you want to call it, like around how should the project interact with like corporations who might want specific, how does money change the open source project? These are things that I don't really have much experience with, so it's good to get these kind of get some guidelines down in place ahead of time before we really run into any issues around that.
Yeah, do some planning in that area. So all of these wish list items to are places where people are encouraged to come and help out, and if they're technical items, they could help fund those activities or give code contributions, right? So these are the spaces that the Dask ecosystem, even if might be going, even if Dask itself, is kind of in a different mode where it's not. I think, Jim, during our pre-discussion, you called it green fields, right? Like, that's a fair description?
Mm-hmm.
Yeah. All right. So other than governance, what are some of the other points that you guys wanted to bring up?
Tom, can you take over? Like, my battery is going to die. I will be 2 minutes.
Technical difficulties, as always.
No worries. Yeah. So the first, in the past, the thing that's worked really well for us is finding a community of users and then finding what their problems are and helping them scale out to larger things. So, Pangeo is kind of a good example where Xarray was a pretty early adopter of Dask Array specifically, to use it internally. And there were some frictions, around it not being developed in Dask itself. So there's Dask Array, Dask data frames developed in Dask itself. Xarray was kind of outside of Dask, and there were some frictions, like it couldn't do things that Dask's own collections could. So that led to the development of an interface where anybody can define this interface, this Dask collection interface, and then get access to all of the good features of Dask. So Xarray is really on a first-class parity with Dask data frame, Dask Array, even though it's developed outside of Dask itself. Other examples are like, Zar. That's a perfect example. Is it's this problem with HDF5 was slow on the cloud because you couldn't do random access to subsets of the data. So some of the Xarray and Zar developers sat down and wrote a Zar backend for Xarray and got it working well with Xarray and Dask. So that's kind of like been the most productive way. So if you have a library that does like solar observation or something, and are having trouble scaling, then definitely do reach out to us, and we can help you get going with getting Dask and getting your workload distributed to a cluster or whatever, if that's what you need.
Sounds great. Yeah.
Yeah.
Were there especially the bits about helping the community, different communities and different domains scale up and kind of scale out? That seems particularly valuable. So are there particular communities that you're looking to, or like domains that you're looking to target that are of interest? I mean, I know ML is one of them, but are there others?
Yeah, that's the one for me. It's kind of one at a time. There's Dask ML, which is kind of a collection of things for distributed parallel machine learning in Python. So part of that's just working with the Scikit-Learn developers on the joblib backend. So that's a way to take Scikit-Learn's existing way of parallelizing computation on a single machine and then spreading out to many machines without the users really having to do anything other than connect to their cluster. So machine learning is a big area, and if you're interested, Dask we have a issue tracker where you can submit requests and things that would be useful for you. Even just things like middle of last year, I went through with Scott Sievert, a big example of the Criteo data set. It's like this big, gigantic data set. I think it's from an ad company, so it doesn't really matter, but it's a really big data set, and that turned up some issues in Dask, like we don't handle sparse data well or things like that. So even if you have just workflows that aren't working well for you, then definitely feel free to open issues there, and we can take a look and see what can be done.
Yeah. Okay. Very cool. Thanks. David, did you have something you wanted to ask, roadmap-wise, or Jim, did you want to?
Well, are there any issues on the Dask-ML roadmap that'd be interesting to discuss? There's a couple items that I see listed, like gradient-boosted trees and HTTP scan. Or do we?
Yep. So for gradient-boosted trees, there's like XGBoost is the most popular one, I think. There's a Dask XGBoost package that kind of hooks into, it's in the weeds, but XGBoost has a distributed runtime, and Dask XGBoost basically gets data from Dask workers to XGBoost distributed mode. So there's that. There's also a new project from Olivier Grizel, and who's a Scikit-Learn developer, and someone else whose name I've forgotten. Sorry, but they're working on a pure Python and Numpy accelerated gradient boosted library.
Cool.
And that could be quite a bit easier to interact with from Dask, just since it's all pure Python. XGBoost is kind of hard because it's a big C program, and it's kind of hard to hook into sometimes. So that'll be interesting to see. That no work has been done on distributing that yet. HGB scan is a very popular clustering algorithm from, I actually don't know the original authors, but I think Leland McInnes has a library for it in Python. So that'd be something that's fun. That'd be fun to distribute. That and UMAP, another dimensionality reduction algorithm. So there's like, we have a list label, it's like roadmap or wish list. There's those like algorithms that might be useful. So if you're interested in adding to that list or potentially working on some of those, that would certainly be helpful.
Yeah, sounds like a great place for folks to jump in and help contribute or fund. So, Jim, is there anything on your wish list or anything on other people's wish lists you'd like to bring to the fore?
Yeah, so a lot of the stuff that I care about is mostly been mentioned already. I think when I walked in, Tom was talking about our interactions with other communities. That is, so my main goal personally for the next year is to increase the number of developers and to get us involved in more projects.
Yeah.
And so that's really kind of an outreach effort there. It'd be good to find a new community. We found a lot of success with the X-ray project in atmospheric computing. For stretching and pushing on Dask to make it better. And so similar other communities would be good for improving the core infrastructure and also just helping the ecosystem in general. So it's more of a wish list for others to say like, hey, you could be useful here than for us to fix a specific thing.
Right.
We need some direction.
Yeah, that makes a lot of sense. So yeah, if you want to be a part of that conversation, it sounds like folks are more than welcome to join it. Mm-hmm. Is there anything else you wanted to say on the wish list discussion, or are we good to wrap up here?
I could talk a little bit about deployment.
Yeah, that'd be great.
Yeah, so we can currently deploy on basically any cluster manager that people care about. There's a generic interface that people can fill in, and then things should just work. So we currently have core projects for Kubernetes, Yarn, traditional HPC job queues. Let's see, what else have people written?
You're talking like Torque, etc.
Yes,
that kind
exactly.
of stuff. Yeah.
If you are at a university, you likely have access to one of these.
Right.
Probably in like a library basement. We have those. And then there's other people have written ones to deploy on like Fargate, which is an AWS product. Anyway, so there's some desire to more unify these. Currently, they kind of push, and there's a generic interface, but other projects like JobQ, the HPC one is more built out than, say, the Yarn one.
Mm-hmm.
I don't know what people's needs are. So there could be some uniform things we could pull back into core to make these projects a little more similar. At the same time, I'm not sure how useful that is. I don't expect people to swap deployments that often. So if you have your code, you probably have your cluster. You're not likely to swap between Yarn and Kubernetes frequently.
Right.
Really, I think it's we could use some new people with thoughts on this. The people that have been thinking about it now, managing different cluster infrastructure, we know our needs, but we don't know everyone else's needs.
Right. That also sounds like an area where, I don't know, say you were a cloud service provider, and you wanted Dask to work on your cloud, that would be an area where you could contribute code or money to make sure that that your particular cloud gets supported too. So yeah.
Same with file systems. Like we can read or Google or Amazon or all sorts of things, but we could probably figure out a more uniform way to do that. Martin Durant has a file system spec project he's been working on to hopefully unify that a little bit better. Right now, a lot of the file system spec stuff exists in Dask in a weird amorphous way.
Is that related to intake at all? Or
yeah, intake can use that too, but it's a generic file system backend.
Okay, yeah, we had Martin on, or David had Martin on. I wasn't there, I believe, for a discussion of intake from a couple episodes ago. So if folks want to go and brush up on that, they're welcome to too. So, all right. Well, at this point, we're going to wrap up our wishlist discussion, and we're going to move on to our Q&A discussion. So we've gotten a few good questions here in the questions stream. So, David, you want to ask the first one?
Sure. We have a question from Timothy Egbert. Will Dask support the integer NA extension type when Pandas 0.24 gets released? And if so, will it be able to read and write Parquet files?
Sure. So yeah, I'll take that one since I've been working on that. I did the Pandas release candidate this morning, so go download that, try it out. But for those that don't know, Pandas 0.24 will have optional support for integer columns with missing values. Dask will be able to benefit from that right away. That's kind of partially a testament to Dask's design. Is that it really is just building on Pandas. So we didn't have to rewrite Pandas to write Dask data frame. We really are just using Pandas. So Dask will be able to use that as well. And then the second part of the question is, will it be able to read and write Parquet files? Dask and Pandas can already read and write Parquet, so that's fine. Perhaps the question was about reading and writing Parquet files with these integer NA columns. That has not been sorted out at the Pandas level yet. We need to work with probably like the PyIO and Fast Parquet developers to figure out how these new extension array things should be serialized, and we have not done that yet.
Excellent.
Okay.
Piaru asks, the Dask stream seems like a cool visualization tool for tracking computations. Say if one would have a Python script doing computations, not using Dask, would it be possible to visualize the computations using the Dask stream feature? Say by wrapping the script main function with Dask or something similar?
Yeah, so really the task stream shows computations that Dask knows about. From a user perspective, if you're trying to write some custom thing, you could use Dask delayed, where we also have a features interface. If you're familiar with features, a similar thing, you can drop that in. And then you'd be delegating certain functions to show up in the task stream. And as those computed, they would show up in the stream as it went along.
Right. Yeah, that makes sense.
Ralph Gomers asks, can you say something about typical behavior of the startup time of the distributed scheduler? I imagine it's way faster than, say, Yarn. How much does it depend on the hardware configuration?
So that's a complicated question. So the scheduler and the cluster in general are just Python processes. So they spin up in a second. Like they're very quick to start. But if you're talking about a cluster, you're probably using some kind of cluster management to manage how long the cluster lasts, starting it up, scaling it, asking for resources. And that then is dependent upon the resource manager you're actually using. So as I said before, we can deploy on Kubernetes, we can deploy on Yarn, we can deploy on traditional HPC job queues. And that all depends both on like how heavily used your cluster is, the configuration for your cluster, what resources you're shipping around. If you're using Yarn, you might be moving an archive around. That takes some time. I would say my experience on Yarn in like a non-real world situation has been seconds, under a minute for sure, usually around like 20 seconds-ish to start a cluster. Kubernetes can be faster or slower. It's really dependent on the situation.
Yeah, leave it to Ralph to ask the fun ones. Jonathan Moore asks, does anyone have work plans or interest in automatic differentiation calculations done with Dask? Sounds like a place to contribute.
Yeah, no, for sure. I don't think anyone on this call has plans for that, but if you are interested in it, then certainly would be worth looking into. And I'd be curious to see that be done or maybe help out with it. It's a fun area.
So one interesting thing on that is there's a couple libraries that do automatic differentiation based on Numpy. So following the Numpy API. Yeah. Since Dask Array follows the Numpy API, if they could make it separate from Numpy and just bind on some Numpy-like object, it would likely just work with Dask Array.
Yeah, that's I would also personally be interested in that one. That one's a good question, Jonathan. Well, at this point, we're going to wrap up our Q&A section since I see no more questions in the feed here. This is our world famous. So now we're going to transition to our world famous rant section where we each get about 15 seconds to rant about whatever topic we want. Jim and Tom, it is your soapbox. Tom, I see you have something. So if you want to go ahead and rant first.
Sure, Python 2. Mainly because last night I was staying up late trying to fix our CI, which was only failing on Python 2 because something wrong with warnings not being cleared or something. I didn't understand the problem because I was angry at Python 2 for failing. So Pandas is dropping it in a couple months, which will be quite nice.
Yay.
Yeah.
Jim, do you have a rant?
Yeah. I've been writing a lot of Java code lately, making things work with Yarn, and the biggest issue I have found is that none of it is documented. The documentation is other projects that happen have already written code using it. Please document your code. Please don't write just doc strings. If you have a method that says get memory, please tell me the units that the memory is in. It's very frustrating. Thanks.
Hear, hear. David?
Sure. Mine's a little less technical. Every now and then I have a revelation that I really would prefer not to own a car or multiple cars like I do. This is especially true when I find myself having to replace one.
Of course. My rant is technical as well today, so I'd like to bring to the attention, or to everyone's attention, the fact that the CondaForge compiler migration is finally nearing its completion. The date for the great switchover is going to be next Tuesday. You can read more at condaforge.org/status. That's all that we have time for today. Thanks for watching and thanks for listening. You can find us on Twitter at Quansight AI. If you are interested in funding open source projects, including Dask, you can find all of the project roadmaps at quansight.com/project. Jim and Tom, well, where can people find you and Dask?
Yeah, so Dask is all on the Dask GitHub org. We have an issue tracker there. We also have links to, there's a Gitter channel if you wanted to chat, and we prefer people don't use that. It's not easily searchable. So we'd rather you file issues or ask questions on Stack Overflow. And then me personally, my Twitter is Jiminy Christ. Jimmy Christ was taken. So. Tom?
And I'm on Twitter at Tom Augsburger.
Excellent. Thanks again, everyone, and join us again next episode for an electrifying discussion on PySpark. All right. Bye, everybody. Bye.